My name is Pascalis, and I want to show you how I trained this robot in a simulated environment and transferred it to a robot in a real environment. Here on the upper left, you can see the simulated robot is collecting this magenta colored box, and on the bottom right, you see the real robot who is doing exactly the same. And the real robot didn't, so this behavior wasn't programmed to the real robot, it was completely learned using machine learning. And yeah, how I did this, I will show you in the next slides. So first of all, I created a simulated robot or a digital twin of the real robot. This was done in Unity and it's quite easy to do so because the robot isn't that much complicated. You have the body and two wheels, and in Unity you have different ways to create like physical behavior. One is this rigid bodies that you can see here that are highlighted, and those rigid bodies have different specifications like mass, drag, angular drag. They can use gravity or can be influenced by gravity. Um, and yeah, so this is how I like created the digital twin of the robot. And for the real robot, I used an mbot. So this is an mbot from the company MakeBlock. And it has a controller and two DC motors, which are connected to two wheels, and a low friction wheel on the top. And I modified the robot a little bit. So I added a Raspberry Pi Zero with a Pi HQ cam so that the robot can have visual observations, and also connected this Raspberry Pi Zero via a serial connection between the with the mbot controller, and use a power bank to power the Pi Zero. Now, the simulated robot, also called the agent when we talk about machine learning, is in a simulated environment. So the simulated environment, in fact, is this capsule which has a 360 degrees picture of my living room attached to it. And as you can see here in the middle, there's the red target that the robot is supposed to collect, and the robot in the middle. So, and this is what the robot actually sees. So this is the capture of the virtual camera. Now I did this 16 times, so I had 16 simultaneous environments, and used the ML Agents toolkit from Unity to train the robot to collect the red target. And then the trained neural network was then transferred to the real robot. And this was done by streaming the camera picture of the real robot back in Unity, and sending the action values to the real robot. Now here you can see the real environment and the real capture. So you can see it's quite similar with the simulated one, so therefore it works quite well. As you can see here, there's the robot, and from this distance the picture itself is only a few pixels. So the picture of the target is only a few pixels wide, and the robot still managed to collect the target. It's kind of wanky, but it still gets the job done. The thing why the robot completely turns around when he touches the object is because of the camera, which is slightly higher than the target object. So once the robot touches the target, it doesn't seize it anymore and tries to look for it again. But yeah, even though the training wasn't randomized, so I didn't randomize the brightness or any other visual aspects, it still does a pretty good job collecting the target. Now what I want to show you is also the trained neural network. So this is how the network looks like when you use Unity's ML agent. So you have here the visual observation on top, and then it goes into convolutional operators and into a leaky relo activation function, and the same again, and then some other math, and on the end you get the continuous actions. And in my case, the continuous actions are the values for the two motors. So we have -1 to 1, while -1 means that the wheel is completely turning backwards, and 1 that the that the wheel is turning 100% forwards, and 0 that the wheel isn't turning at all. And we have two DC motors, so M1 and M2 represents motor 1 and motor 2. What I find also quite interesting is how it actually looks like. So when I give the robot, for example, this picture here with the target in the middle, and yeah, this is how it looks like in the red, green, and blue channel. And after it goes through the convolutional operator, so this is what the filters look like, and in the activation, in the first activation function, you can clearly see that where the target is, there's a high activation taking place. Yeah, so same if the picture, like if the target is quite on the left of the picture, you see that the activation takes place exactly there where the target is on the picture. Yeah, that's it. Thank you for listening. Bye.